Hi everyone, my name is Chris Larson, and today I'm going to talk about databases, including the types, uses, and questions to ask when deciding on the best one for your project. So what is a database? Databases make up much of the backbone for most of the world at this point, with almost every piece of software and website being driven by data. This makes database software extremely valuable to companies looking for stable, supported DBMS. Now, you'll hear me refer to database software and DBMS interchangeably, and while there are technical differences, for our purposes in this presentation, we'll define a database as software with native language support like SQL and not other UI heavy database apps like MS Access, Excel, or Google Sheets. In short, a database is software that helps you organize, store, and retrieve data. Database software exists to protect the information in the database and ensure that it's both accurate and consistent. Its functions include storage, backup/recovery, presentation, and reporting. It can also help your team with multi-user access control, security management, and database communication. Databases have a variety of uses, but this sums up the main idea of what databases are used for. But then once we get past these, there's another choice. SQL versus NoSQL, which stands for Not Only SQL, is mainly about how the database keeps the data stored and how you get it back out. SQL databases are something called relational, which means they keep the data in tables. The other kind of database is NoSQL. There are a lot of different kinds of NoSQL, and the thing that they have in common is that they do not use SQL to get the data back out. However, they can be good for different reasons, and in a lot of cases, either will do. A lot of SQL and software development involves CRUD, which stands for creating, reading, updating, and deleting. These query commands work for a variety of different software databases, and 7 of which we'll compare to see which one is the best. NoSQL databases have grown in popularity recently, but they're typically specialized, and because of this, their focus isn't normally on SQL, but this allows them to solve problems that SQL isn't great at. For example, MongoDB stores data in a way akin to web browsers, and records don't have to have the same fields. Let's discuss an example using social media. When you log into Facebook, the query will return something like the text of all the friends of the user for the past 3 days, plus the names of the friends and the date of the post, sorted in reverse order, that the user hasn't seen yet and hasn't been hidden. Another example could be for sales business. You can use SQL to find out how much profits the business made in a day or to track the inventory of a product. You can use data mining to find interesting connections in the data, compare users by the number of products purchased in a day, or to see the most popular products amongst customers. Now let's pause and think of any other examples in software development or even business where a database management system would be an effective solution. Did you think of some? Here's a quick list you can pause if you'd like to get some more ideas on what use cases are out there. It's important to understand these use cases because it's the first set of questions you should ask when deciding on a software database. Behind the scenes, there are different terms like hierarchical, relational, object oriented, and network, all denoting the way a database management software organizes data internally. Moreover, the cost, size, and performance of a DBMS vary concerning on the organization's requirements and use cases, therefore should be evaluated accordingly. Desktop databases are designed to run on a single machine. They're generally inexpensive and simple, but because of data availability, storage, and functionality limitations, they're generally not recommended. They're mainly used for testing purposes, a prime example being SQLite. Web-enabled databases provide everything a standard database does, but all functionality can be utilized online, and all the data can be accessed remotely and interactively. Common components of a web-enabled database system are permanent online access, a web server and firewall, and application delivery via online database software and a website. A web-enabled database system is often coupled with a desktop platform. Server databases are typically used to manage massive data stores, allowing multiple users to simultaneously access, modify, and update data, ensuring that data is reliable and consistent. While server databases are more expensive than other solutions, they are also more flexible, scalable, and powerful. Now that we understand the 3 main types of databases, let's dive into the most common form, a relational database management system. Relational databases use structured query language, or SQL, to present data in tabular form and provide relational operators to manipulate data in those tables. Most enterprise DBMSs employ some form of relational database, especially for use in web applications. Relational databases are especially beneficial for when your app needs to handle some complicated querying or when you want to make managing and manipulating data easier, like not having to manually join tables. Relational databases mean that data is stored in multiple tables, something akin to Excel. So for example, on Canvas, there might be an announcements table and a people table for each course, and in the announcements table, each post will be a row with different features like the text of the post, the name of the user who posted it, and the ID number. You then have to cross-reference that into the users table and retrieve the relevant bits of info, like just their name in the above example, but that users table probably stores loads of other stuff about the user too. One of the biggest benefits of a relational database, in my opinion, is simply not having to worry about storing stuff twice. Using our previous example, what we wouldn't want to happen is something like if the announcement table stored the user's name, then if they post 500 times, their name will occur 500 times in the database, resulting in a big waste of space and performance. But if you simply store their ID number, then all you have to do is link back to the single record that contains their name. Changing that single record will update the name for all their previous posts. Oracle is one of the most popular RDBMS creators, mainly writing their database in C, C++, and Java. Because of Oracle's reputation and the price tag with running a database on their servers, they provide a very powerful and secure database with really well-written documentation. They're known for their optimal performance and use of less space, and some of the major functionality provided by Oracle are cloud, document store, key value storage, graph DBMS, PDF storage, and blog. But if we're to summarize Oracle DBMS benefits, it'd be performance, scalability, high availability, security, and data warehousing. Next is MySQL, one of the most popular RDBMS used by major tech companies such as Facebook, Google, Twitter, and Adobe. MySQL is provided by Oracle for free when they acquired it in 2009 from the Sun Microsystem acquisition. And recently, Oracle released the latest version, MySQL 8.0, which ensures better data recovery and upgraded the recovery options. To make money though, Oracle offers MySQL through different versions that all have different features. There's the enterprise version, standard version, and classic version. MySQL is widely used in web development especially, and some of its major functionality is its support for Unicode, replication, transactions, full text searches, triggers, and stored procedures. You can also see it supports all the most common languages, C, C++, Java, Perl, PHP, Python, TCL for client programming. And MySQL can be summarized as having high performance, being secure, flexible, and reliable, and it works best when supporting large databases, up to 50 million rows or more in a table. SQL Server can go by a few different names common in industry: Microsoft SQL Server, Microsoft SQL, or MSQL. SQL Server is a fully featured RDBMS. However, this can mean it's a bit overwhelming for someone learning. The database was launched in 1989 and has grown to be one of the most popular relational databases today. Written in C and C++, and also since it's developed by Microsoft, it works well with Microsoft products in Windows, but it also works on Linux too. However, it is platform dependent. Like Oracle with MySQL, Microsoft has released several editions for SQL Server as well, including Azure SQL Database for the cloud, Compact Edition, Enterprise Edition, which is the version used at most companies, and the Developer Edition. The main takeaways are while it's also a highly secure, high-performing database, it also has some unique features. For example, one of the features that makes it unique is how it uses data compression techniques to optimize space. It can also be integrated with non-relational sources like Hadoop or MongoDB, and it also comes with a well-made UI that lets users see the creation of tables and view the different changes to the database, and supports hosting so multiple people can work on the same database at once. PostgreSQL, commonly pronounced Postgres, is an open source object relational database, but it also can create and work with NoSQL databases. It's written in C, and its popularity is increasing day by day. Like MySQL, it works well with large amounts of data, and companies that use Postgres include Apple, Cisco, Fujitsu, Skype, and IMDb. PostgreSQL runs on all the major operating systems and works for all three types of databases that I discussed earlier: systems, web, and server databases. Some other features that I think Postgres does well, especially when compared to the others, is it's specifically apt at building fault-tolerant environments, managing data, and protecting data integrity, as well as being able to create, manage, and query custom data types and methods. Postgres is easy to scale, can move data around pretty easily comparatively, and can support JSON, and has a bunch of helpful predefined functions. It also supports things like table spaces and stored functions and procedures. So the main takeaway for Postgres is that it's a very robust, especially when getting into the details comparing it to other databases. IBM DB2 was originally made to support the relational model, but recently IBM has expanded it to support object relational features like Postgres, and it can also support non-relational structures like JSON and XML. Since it's from IBM, something unique is its integrated dedicated AI capabilities to manage complex data. While this database is primarily used on the cloud, it can also support private system or server-based databases. Because of its cloud focus, it's really easy to install and is accessible. Overall, an up-and-coming database that's comparative to SQL giants like MySQL and Postgres and should be watched more. So now that we've discussed SQL, let's expand on what we've been talking about and discuss NoSQL. This stands for not only SQL, not no SQL at all. And if there's one thing to take away from this presentation, it should be that. The distinction is because SQL expects the database to be structured in tables, almost like a collection of Excel spreadsheets. However, data may not always fit this assumption, so NoSQL is the opposite, a database system that doesn't use SQL, that doesn't follow the table spreadsheet idea of the SQL databases discussed earlier. NoSQL databases were used for more niche roles, but are becoming increasingly more popular as their functionality improves. For example, in big data, where you have hundreds of computers working together and you need the scaling power that something like MongoDB can provide. MongoDB is considered document store database, which means it keeps records in a key value style akin to a hash map in Java or dictionary in Python. The thing that makes MongoDB NoSQL is that querying is done through a JSON format API, which uses internal memory to process large data sets simultaneously. Since I said NoSQL works best for specific use cases, let's get into some examples for MongoDB. It can be used for mobile apps, big data analytics, IoT, among others. Some features for MongoDB are it's extremely reliable and really strong data migrations, making deployment flexible, and the queries are easily optimized for the output you're looking to get. Elasticsearch is another NoSQL database based on a search engine that offers a full text search and analytics engine. It's nice because it provides an HTTP Web 8 UI and schema-free JSON documents. Major companies that use this include Wikipedia, The Guardian, Stack Overflow, and GitHub. Elasticsearch is massively scalable, being able to reliably handle petabytes of structured and unstructured data. The database is document-oriented, which results in higher performance, multi-tenancy, and extremely fast search capabilities. While the majority of DBMSs have a UI to work with, they're not always the best, and so a popular thing to do is use visualization software to interact with your DBMS. So basically, you have a database client like DB Visualizer or dbeaver or SQL Plus, which connects to the database and allows users to run SQL statements and interact with the data. However, the UIs for the databases aren't unusual because the MySQL Workbench UI is really nice, and most cloud DBMSs require you to use their web-based UI to interact with your database. On the topic of cloud-based databases, let's talk about Cloud SQL and Amazon RDS and Azure. First, the reason many companies are moving towards cloud-based databases is the fact that an on-premise database software uses the hardware and support of the organization, which means the company needs higher IT to maintain and solve problems related to the infrastructure. Cloud-based databases are owned and managed remotely through the internet by a provider separate from the organization using the software. Since it's managed by another company that focuses on supporting the database, it's generally easier to customize the database to the company's specific needs and scale when needed since it's not limited by hardware. So if I had to recommend a single database for someone to learn that will not fall out of fashion in the next 5 years, be pretty easy to learn, and also useful for learning databases in the first place, it'd definitely be PostgreSQL. The main factors behind this are the fact that it's powerful and more robust than SQL Server or MySQL, and it has just as good a performance as the others and works with all the major development environments. Especially for starting out, the fact that it's free is a big plus, since unfortunately a lot of database software isn't free, so it's hard to practice with them. At the end of the day, though, they're all modern databases written by people that know what they're doing, so for most use cases, any of the ones mentioned today will work with a competent software engineer behind the helm. The difference comes down to features that help the software engineer get the database up and running the fastest and most securely. The big questions you need to ask yourself when deciding on a database are things like, do you want a relational database with columns and foreign keys? Then any of the big SQL databases will work. But if you want a document store, most will work almost equally, but Postgres and MySQL are the ones that can use JSON for columns. There's a bunch of tiny details that differentiate all the databases from one another, but those are rarely made apparent, and most databases are satisfactory for most use cases. The main thing I look at, or when I'm working with databases, is choosing one where the community is big enough that I can search for help with issues I'll inevitably run into, and I'll more often than not be able to find the answers to my problem. And that concludes my presentation. Here's a list of the sources I used for this project if you want to see where I looked around. And thanks for watching my presentation on comparing different database management systems. Have a good one. Bye.